Position versus time lab, you were asked with each run of the car to collect 3 pieces of data. The first was the interval time, which means the time from A to B. The second was the time it took the car to go through photo gate A, and the third was the time it took the car for the photo to go through photo gate B. Our next step in this lab is to calculate the speed of the car at photo gate A and the speed of the car at photo gate B. Last week, we learned that speed is equal to distance over time. In this case, and in all our labs, we know that the distance that we're using is 5 centimeters because that's the length of the wing of the car. But now, this is where we're going to use these really small decimal numbers to calculate the speed at A and the speed at B. So in order to calculate the speed at A, so speed at A, we're going to use 5 centimeters divided by the time at A. So for example, if I'm calculating the speed at A when the photo gates were 10 centimeters apart, I take out my handy dandy calculator, I'm going to do 5 divided by, because 5 is my distance of my wing, the time at A, so 0.0793, so 0.0793, that equals 63.05. So that's I'm going to write here, so 63.05, because the speed at A is calculated with the time at A. For speed at B, I'm going to follow the same steps, except speed at B, it's going to be 5 centimeters because that's the wing of the car, and it's going to be using the time at B. So speed at B uses time at B. So taking out my handy dandy calculator, we're going to do 5 centimeters divided by 0.0481 seconds, because that's our time at B when the photo gates were 10 centimeters apart. So 5 divided by 0.0481 equals 103.95. So 103.95. I'm going to follow that same procedure all the way down. You might notice that this column is pretty similar, and I want you to think to yourself why that could be. But the speed at B should gradually increase, and you're going to try to figure out the relationship between time and speed. When you're done with this table, you need to get my initials at the end.